Okay, so we are talking about the chapter 6 quiz, number 5. So the problem asks us if we have a copper 1 oxide can be oxidized to copper 2 oxide by the following reaction. If the enthalpy of formation delta H sub F of copper 2O is equal to negative 168.6 kilojoules per mole, find the enthalpy of formation of copper oxide. Okay, so we're given this chemical reaction where we have copper 1 oxide plus 1/2 O2 goes to Cu. Oh, stop. And we're told that the enthalpy of this reaction is negative 146.0 kilojoules per mole. Whoops, per mole, sorry. Okay, so this is a Hess's law question, right? And Hess's law says that the enthalpy of the reaction is equal to the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. Right? And we have to multiply them each by their stoichiometric coefficients here. So let's start off with delta H of the reaction, right? We know this guy, so we can plug that in. That's not a variable. And our delta H for our products, right? We're looking at this guy is our product. So we would have 2 times the enthalpy of formation of copper oxide, right? Minus the enthalpy of formation of this guy and the enthalpy of formation of this guy. So, for oxygen gas, what's the enthalpy of formation?
0.
It's 0.
It's 0, exactly, right? So the enthalpy of formation here is equal to 0, so we don't need to include it. So here we have the enthalpy of formation of copper 1 oxide, right? So we know this guy and we know this guy, right? So we can solve for this guy. So I have negative 146.0 kJs per mole. is equal to 2 times delta H sub F of copper 2 oxide minus 168.6 kilojoules per mole. So minus minus gives us a plus for this guy, right? But we want to get it to the other side. So when we move it to the other side, we're going to subtract it. Does that make sense, guys?
Yes.
So minus minus gives us a positive, right? But we want to get rid of it on this side of the equation so that we can solve for the delta H of formation for copper 2 oxide. So we need to subtract this from both sides. So what does this give us?
Negative 314.6.
And I need to divide that by 2.
Negative 157.3.
Negative 157.3 kilojoules per mole. Questions about that problem?
It was way easier than what I was doing.
You know what? It's funny because I would say that's the number one thing I see with Hess's law problems is that the students just try and make it way harder than it is. It's actually a pretty simple procedure, but it's also really easy to mess up a sign here somewhere and then get a wrong answer, right? But the most important thing with Hess's law is don't forget about the stoichiometric coefficients, right? Those guys are important. And make sure that you've plugged everything in the correct place, right? A lot of the time students will accidentally put reactants and products, right? So just make sure you've got that correct. Other questions about that problem?